Draw a logic circuit for the following boolean equation. So we have been given an equation and we are told to draw a logic circuit. Logic circuit consists of gates or else logic gates. So we shall be drawing a circuit made up of various gates according to our equation. Our equation is y is equals to a not b then c or a, that is not a, b c, or a and b complemented and c. So in this case now, when you are drawing the logic circuit, you have to know which gates have been applied, and in that case you use or else you determine that by using the operations that have been applied, the signs. For example, plus sign represents OR operation, so you know that in this case now we applied OR gate. As you can see, these terms have been multiplied. A and B, C are multiplied. In this case now, that is multiplication, and the multiplication is normally represented by AND gate. So you apply the necessary gate at every term depending on whichever operation is there. So from this equation, our distinct inputs are A and B, C. So we can have our A, we can have our B, we can have our C. Then before we can get the expression representing Y, we can go step by step and determine every term in the equation. So in this case, let's start with the first term. A multiplied by B complement multiplied by C. So in this case, we have to complement B before we can get that term. Here we get B complement. So this plus the others, we pass them through AND gate because the three are multiplied. So at this case now we get our first term A, not B, and C. After that, now we go to the second term where A is complemented. So we can take A from this point and we maybe negate it to get A complement. Then this A, we shall join it with B and C when they are not complemented. So we shall take B at this point when it is not yet complemented. Let me have it like this. So this is A, this is A complement. So we take B when it is not complemented at this point. These are just joints, meaning we are not connecting them at that particular point. So this is B, we have taken B, and we take C. So C is here, so C we can extend it that way, or else we can use this. Let's take it from here. Let me have it from here. So these three now, we pass them through AND gate to get not A, B, C. Now we have achieved our first two terms. We go to the third term. In the third term, it is very important to know that these two, they have overall complementation. So you can not take the individual complementations, then you pass them through AND gate. You have to take the A and B when they are not complemented through AND gate, and then after that you pass through a NOT gate, the product. so that you get the overall complement. So in this case now, we take A and B when they are not complemented. So in this case, at this particular point, B is not complemented because our line is from this point. So we extend it to get B. Or we also take A. When not complemented from this point, we take it from here. So that is A. So these two, we pass them through AND gate to get now the product. And this product now we pass them through NOT gate to get now it having our overall complementation. So this overall complementation is the one now which is now passed through AND gate with C, which is not complemented. So C, which is not complemented, as you can see from this joint here, you can also take it from here, but we can extend this one. So we have from here, we extend this downwards. So this is C. So these two, we pass them through AND gate to get AB overall complementation C. And now, as you can see, now we have the three terms in our equation. Now the three have been added, meaning they have been passed through OR gate. So we pass them through an OR gate. You have to draw the symbols very correctly. So that is OR gate. And in this case now we merge with Y, where Y now will be now these three added together. So we get now at this point we get A, B complement C plus not A, BC plus not A, that is AB complemented C. So that is the answer for that question, and that is why the question is given 5 marks, because it has a lot to be done. So that is the logic circuit.